Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at the standard function type, which is a very nice convenience in C++11 that lets you easily define a type equivalent to, well, it can be used to reference any callable type in C++11, which basically means anything you can call with round brackets. So let's include here functional, and I'm also going to include some other things. I'm going to include vector here, and plus I'd like to include, let's include algorithm as well, algorithm. So if we create a vector here of, let's say, string, let's call that vec, and let's initialize it with this curly brackets syntax like this, 2 and 3. Then we could count, let's say, the number of strings in there that have three characters in them by using COUNTIF from algorithm there. So we pass vec.begin, vec.end, and then we need to pass in something that can actually evaluate each of the items in this vector. Let's try a lambda expression. So we could pass in capture brackets, and then the lambda expression is going to have to accept a string that it's going to check. And we need curly parentheses, and we just return test.size equals 3, let's say. And if we do that, we can output COUNTIF, the results of COUNTIF directly with a cout. Let's just do an auto format there. Well, that looks really terrible, but okay, maybe it's better, maybe it's a bit clearer if I say int count equals COUNTIF, and then we can just output count, so cout count. So I think we've seen all of this before. We can pass lambda expressions like that. If we wanted, we could make this size here a local variable as well. We could say int size equals, let's set this to 5. We've got one string in there with length 5. We could capture that here, put in size, let's capture it by value, and put in size there. So we expect to find the answer 1 here. So that works. Now COUNTIF actually lets you pass in a whole range of different things. Let's copy this. Instead of a lambda expression, we could pass in, let's say, a function pointer. So let's create a function here. Let's say, let's call it bool check, maybe, and we'll make it take a string. I think there's no reason why we can't make this a reference, and we can say return test dot size equals 3. So we can actually pass this in here as well. So we can just pass a function pointer, and if we run this, we should get the same count again. Let's just check what we've done here. So redefinition of count. Yeah, I need to get rid of this int, because we can't have two variables called count in there. So we get a count of 2, and we can even pass in a functor. So let's have a class. Let's call this class check, and in there I'm going to define, it's going to be public, and it's going to be bool operator round brackets, and this is going to take a string. We could make it a reference if we're not planning to pass in a string by value, like as a string literal that we've actually typed. We can make this reference. Let's call it test again. Let's say return test.size equals 5, maybe, just for a bit of variation. So we could define a object to check directly here if we want. So after this closing curly bracket, we could say check 1, let's say. And we can even pass that to COUNTIF. Let's try it. Format that. and maybe I'll get rid of some of these blank lines to try to group this together logically. In here we can pass in check 1 like that, and this also works. So it's pretty amazing. So we can pass into COUNTIF basically anything that that is callable, in essence, anything that we can type round brackets on the end of to call it. And of course, because this expects something that tests a string in this case and returns bool, and it would have to make sure in this particular case that everything that we pass in accepts a string and returns bool. Now, how does it do that? Well, it uses standard function. So let's create a function here. Let's call it maybe void. I'll just call it run, so I can't really think of a name to give it. Now I've included functional up here. Now supposing we want to say that run can accept, let's say for example, since we've got a bunch of callable things here that return bool and accept a string, let's say we want to say that run can accept anything that is anything that's callable, returns the bool and accepts a string. We just type function, it's a template type, so we put these template brackets after it, and in there we use this really simple syntax. So the return type is, we specify that directly, and after that immediately, still in the template brackets, you'll notice I put round brackets and I specify the parameter list types. So here we've just got string, it could be string, or we could say string reference in this case, and then we just give it a name. So let's call it check, and let's just call check on something here, like well, we can't pass it string directly because it expects a reference. Let's say string test equals and I'll create something with 3 characters, dog, and then we'll pass in test, and we'll just do cout on that. So we're just basically proving that we can call whatever we pass in, which is callable, and whatever it is, it has to accept a reference to a string and return a bool. So now that we've done that, we can pass any of the things we've defined to run. So we could say run, we could pass in a lambda expression. Let's try that. Let's maybe copy this. In fact, I'll paste it here and I'll say auto lambda equals, and let's then pass lambda into here, and I just want to prove that we can also pass it to run like that. So if we run this now, we've got a error. What did I do wrong? I've missed off a semicolon at the end there. So of course it's a complete statement, so we need a semicolon at the end of it, and I missed off another one there. Okay, even after, like, I don't know how many years, 15, 16 years of doing this, I'm still missing off semicolons, at least when I talk and write at the same time. So this works. We can run it and we get naught. Why? Because we've checked that the size of our string, check here, is the lambda expression, and it's checking that size is equal to 5, and we've passed in a string with 3 characters. But the main thing I want to show you here is not the test really, it's just the passing using this function syntax. So we could also run check1. What's check1? It's a functor that also checks if the string size is 5. Well, actually, I'm getting a bit sick of this. Let's put in a 5-character string so we can actually see true. So if we run this, it also works. Amazing. And of course, we can also pass in our function here. You can pass in a function pointer because this also returns bool and accepts a string. It's a reference to a string, which is what we've specified exactly here. So let's just try that as well, and we'll pass in. So it's called check. That's a pointer to a function. Let's try that, and we get 0 because the check function is checking if the string length is 3. So there are some possibilities. Of course, we can use this syntax to define local variables as well. Like if we had a let's say we had some function with a void return type, or maybe let's make it int that accepts 2 integers. So that could be or 2 doubles or whatever you like. Yeah, let's make it 2 ints. We could call that something. Let's call it add, and set that equal to something callable. So let's set it equal to a lambda expression here. So we've got the capture brackets, the round brackets. They're going to have to accept int 1, int 2, and let's put in curly parentheses there, and let's just return 1 plus 2. So now that we've got add, we can just call it like that, and of course we need to pass values in. Let's pass in 7 and 3, so we should get 10. And let's actually see what the return type of that is. So you can see where this is going. So if we run this, then we get 10. So this is just a very, very handy way of creating a type, whether it's in an argument list of a function, a method, or whether it's the type of a local variable. But it's a type that can refer to anything callable that has the return type and parameters that you specify here. So it's very, very nice. So again, well worth practicing this. If you have the patience, try this out on a functor, on a function pointer, and a lambda expression, and that would give you a little bit of practice with all three. For example, you could define functors, lambda expressions, and functions that multiply 2 numbers together, for example, something like that, and check that you can refer to them all with this. Maybe try it in the argument list of a function, or try it as a local variable like this, or all of those possibilities. Okay, so I'll leave it there for this tutorial. Oh yeah, you might want to check that you can pass functors and function pointers to COUNTIF as well. Depends how much patience you've got, but it's worth trying this out at least a little bit. Okay, so until next time, happy coding.